In this video, we're going to take a look at a Leetcode problem called Partition Equal Subset Sum. So given a non-empty array nums containing only positive integers, find if the array can be partitioned to two subsets such that the sum of elements in both subsets is equal to each other. So this problem is very, very similar to the knapsack problem, and I have a video on my channel called Knapsack Problem, a video that I did, and I showed three approaches on that video, and I showed the top-down approach as well as the bottom-up approach, as well as using memoization. How can we use memoization to improve the time complexity, right? So be sure to check this video out. I highly recommend to check out this video before look at this question. So this question is very similar to that question. Basically, we're given an array and we want to find the partition, if there's a partition that two subsets or the sum of two subsets will equal to each other, right? In this case, we can partition in a position where we have 1, 5, 5, and the sum of those elements is 11, and we can also have 11 here. In this case, this is one subset, right? And this is one subset, and they all have equal sum. And then if they have equal sum, then we can just return true. Otherwise, if we have a situation where we have 1, 2, 3, 5, and you can see that the array cannot be partitioned into equal sum. So in this case, we cannot have, like, we have to use all the elements in the array. In this case, like, we cannot say I have 2, 3 as the subset and I have 5 as a subset. We cannot do that. So in this case, we have to use all the elements in the array. So in this case, we have to return false. So let's take a look at how we're gonna solve this problem. But first, I'm gonna show you how we can do this in a top-down approach. Then I'm gonna show you how we can do this using memoization. Then lastly, we're gonna talk about how we can do this using bottom-up approach. So when I first approached this problem, I thought, well, why don't we just get the sum of the entire array, right? In this case, the sum is 22, right? In this case, we have 22, right? So 1 plus 5 plus 11 plus 5, it has the sum of 22. And this has a sum of 11. So why don't we just check to see if this number, the total sum of these elements add up, right, is a even number, right? Because we need to have at least two subsets, right? We must have two subsets in this case. So why don't we just check to see if the sum is even number? In this case, if it's even number, we can just return true. If it's not even number, we can just return false, right? In this case, this is a true, right? I mean, it makes sense, right? But this is not going to work for all test cases. So it's very, very important to consider all the test cases when we approach this kind of problem, right? So so let's say we have something like this, where we have 1, 2, 5. In this case, we have a sum of 8. And is this an even number? Well, this is an even number, right? In this case, it's 0. Is it even number? Then what we know is that then should we return true? Well, we cannot return true because there's no two subsets that each subset sum is equal to the other subset, right? So in this case, we can't. So in this case, we're gonna return false. So what we have to do is we can use that, right? What we can do is we can check to see if it's an even number. If it's an even number, if it's even number, what we can do is we can just return, if it's not even number, we can just return false, right? But if it's even number, there could still be a possibility that there is no subsets there's no two subsets that each subset is equal to each other, right? So what we have to do is first we have to get a sum, right? In this case, the sum, in this case, is 22. And then what we're gonna do is we're gonna divide it by 2, and this is basically the sum for each subsets, right? So basically, what we're gonna do is that for each element, right? In this case, for each element, let's say we have an array of 1, 2, 3, and 4. Okay, so in this case, for each element in the array, okay, we have two decisions. Either we take this item and we include it into our current subset, or what we can do is we're going to ignore it. So we know that the sum, right, in this case, the sum of the array is 10. And if we divide it by 2, it's going to be 5. So that's the sum for each subset. So what we're going to do is, now you can see we have 5, right? This is the sum. This is the sum for the current subset. So either we add the current item onto our subset, or what we're going to do is we're just going to skip this item, right? So in this case, this is the path of taking this, skipping this item, and this is the path of taking this current item. In this case, you can see if we take the current item, the sum is going to be 4, right? So 5 minus 1 is 4. We're starting at the current this position, right? Now, okay, so now we're moving on to the second element, in this case 2. So either we take the 2 or we don't take the 2. In this case, if we don't take the 2, the sum is still 5. If we take the 2, the sum is going to be 3, right? And then we're going to continue moving forward. We say, okay, well, if we have 5, if we should we take the 3, right? In this case, if we take the 3, now we have the sum of 2. If we don't take the 3, we have the sum of 5, and so on, right? Dot dot dot. And here as well, dot dot dot, right? So in this case, we have either we take the 2, if we take the next element, in this case 4, or we don't take the next element 4. At the end, what we're going to do is that if we have a situation where we actually found a subset that is equal to this sum, right? In this case, equal to this subset sum, then we know that we found it. Then we can just return true, right? Otherwise, if we don't found it, if we cannot find it, then we're just going to return false. So it's pretty simple, but what we have to do is we have to do a base check to see if we have a sum, in this case 11. If this is a odd number, then we can just return false right away. If it's an even number, we can return. We have to do this process, right? In this case, we have to check to see if there is a subset that has a sum that is equal to another subset, right? Or in this case, if we have a subset that equal to the sum divided by 2. Okay, so now we know how we can the idea of how we can solve this problem. Let's take a look at how we can do this in code. So to do this in code, what we're going to do is we're going to do this recursively. First, we're going to get the sum, right? In this case, we're going to have a sum which is initially equal to 0. Okay, and because it says that given a non-empty array, so we don't have to do a base check to see if the array is empty. So what we're going to do then is we're going to get the sum. In this case, is basically num sum plus equal to num, right? This will give us the sum of the entire array. Then what we're going to do is we're going to see if this is an even number, right? So in this case, if sum modulo of 2 does not equal to 0, if it does not equal to 0, then what we're going to do is we can just return false, right? Because we need we need even number, so we need even number. We need even sum. Okay, so then what we're going to do is, like I mentioned, we're going to have the sum of the subset. In this case, is going to be the sum divided by 2, and then we're going to start at index 0, and we're going to do this recursively, right, to figure out if we should take the current item or we skip the current item. And then if we found a subset that has a sum that is, so if we found a subset that has a sum that is equal to the subset sum, then we're just going to return true, right? So in this case, we have a half. Half is equal to sum divided by 2, right? And then what we're going to do is we're going to have a helper method, right? So helper method is just going to do this job recursively. We're going to pass in the current capacity. In this case, the current sum that we have is half, right? And then the starting point, in this case, index 0. So we're going to have a private method, so boolean helper. This is an integer half. And we also have a current index, right? So in this case, index. So what we're going to do then is we're just going to have either taking the current item or don't take the current item, right? So in this case, if we take the current item, right? So let's say take. Basically, what's going to happen is we're just going to get the current, get the current sum minus the current item in the array. And I forgot to pass in the array into this recursive method, so let's make it a global variable. So let's say array Okay, and we're just going to make a global variable here. So array is equal to nums. Okay, so what we're going to do is this. We're going to say helper, right? So we're going to say helper, and we're going to pass in the sum. So if we take the current item, we're going to have sum minus array at current index, right? So we minus the current item, minus the current value, right? And then we're going to increase the index by 1 because we are moving on to the next item, right? So this is take. And we also have skip. If we skip the current item, right, is equal to helper, sum will stay the same, and we're just going to move to the next index in the array, right? So that's basically our two answers. And at the end, when they return, they're returning a boolean. Okay. Okay. So boolean. So what we're going to do then is we have to define our base case, right? So what's our base case? Well, our base case is basically if the current index is actually going out of bound, or if our let's say if our sum is actually less than if it's less than or equal to 0, right? Less than 0. If it's less than 0, then we can just return false, right? So if index is bigger than or equal to the size of the array, or if we have a situation where the sum is actually less than 0. If it's less than 0, we can just return false. But what is true, right? Well, what is true is basically when we have a sum that is equal to 0, right? Just like this condition right here. If we have a sum, right, in this case, that we passed in is 0, then we know that we found our subset, right? We basically have all the items on there in a subset, so we're just going to return true. So if sum is equal to 0, then we can just return true. Okay. So what we're going to do next is we're just going to figure out if take or skip is true, right? So if take is true or skip is true, we're going to return true. If skip is false, right? So or take is false, then we're just going to return false, right? So basically, if one of them is true, we're going to return true. So basically, this is how we solve the problem, right? Basically, we just have a check. We have a base case to do this recursively. We're going to see if the current index is bigger than or equal to the array.length, or if the sum is less than 0, then we're going to return false. That means we cannot find it, right? We are out of the range. If we have the sum is equal to 0, then we know it's true. Okay, we found the item, right? We found the subset. And if we take the current item, in this case, we're just going to minus the sum with the current item's value. And then we're going to move on to the next item, right? So by increase the index by 1. If we skip, then the sum does not touch, right? So let's try to run the code. Okay, let's try with a few more test cases. Okay, so it sounds like we got the correct answer, but I'm not going to submit it because in this case, it will give us a time exceed error. So what we're going to do now is we're going to focus on how we can do this using a memoization, right? So because in this code right here, it will give us exponential time complexity because there will be duplicate computation, right? So here you can see we have a third index, right, and with the capacity of 2, and here you can see we also have third index with capacity of 2. So there is duplicate computation. So that's why we're going to have a 2D array to save the data, to save the computer result onto the cache array. And the reason why we need a 2D array is because we have two variables. One is the sum, and the other one is the current. Sorry, the other way around. So this is the sum that we have, and this is the index that we're on, right? So in this case, for that sum at this current position in the array, we're going to compute the result and then save it onto a 2D Boolean array, so that if we encounter the same inputs, then we're going to retrieve that data in our memory. So let's try to do that. First, what we're going to do is we're going to have a Boolean 2D array. Okay, so we're going to call it cache. Okay, let's declare it here. So in this case, what we're going to do is we're going to have a cache is going to equal to boolean. So we're going to have rows, which is going to be the size of the array, and we're going to have the capacity, which is going to be the sum, right, for each and every single situation. So in this case, we have let's bring it down. So we're going to put it here. So in this case, the sum is actually going to be half, right, because that's the number that we passed in the recursive method, right? We're starting at the half of the sum of the entire array. So in this case, because the array is 0 base, so we're going to plus 1 for the half, right? So basically, what we're going to do is that for each iteration, we're first going to do those checks, right? And then what we're going to do is we're going to see if cache at index at sum does not equal null. If it does not equal null, then we can just return cache at index at sum, right? So if we don't have that, right, so in this case, if we have a situation where cache at index at sum is equal to null, then what we're going to do is we're going to first compute it, then we're going to save it onto the cache. So we have index at sum is going to equal to either take or skip. Then at the end, we're just going to return this. Okay. So let's try to run this code. Okay, so basically, as you can see, we're just trying to have those checks, right, to make sure that we're still in the bound, and then we're going to see if we already have the result cached, right? If we don't, then we're just going to compute the result and save it on the cache. So let's try to submit, and here you can see we have our success. So let's try to solve this problem using bottom-up approach. So bottom-to-up approach. So to solve this problem using bottom-up approach, basically we're just going to use the same table that we have using the memoization, and basically we're going to have a row and columns, right? So in this case, the column is going to be the sum for each and every single situation, right? So let's say we have the subset sum is going to be 5, right? And in this case, we have a rows, in this case, is going to be each and every single number in the array. So basically what we need to do is we're just going to we're going to go from the top left, right? In this case, starting at the top left, and go all the way, compute all the way down to the bottom right. In this case, we're going to save the result, and for the current each and every single position is actually computed, and basically we're going to compute it based on the previous row, right? In this case, the previous result. And basically the idea is this. So first we have to define our base case, right? We declare our base case because in this case, if we have a situation where the sum is 0, then all the numbers in this case is going to be true, right? In this case, all the sum, right? So in this case, it's going to be true because there's no items left. Then if we have 0, right, just like I showed you before, if we have 0, the sum is 0, then we're just going to return true, right? So that's kind of like our base case, and that's what we did here. Is if the sum is 0, then we're just going to return true, and that we save it onto the cache. That's our first step. The other step, the second step is basically we're just going to declare our first row, right? In this case, first row we have only one item. In this case, we have 1, right? So 1, in this case, if the sum at this current position is 1, 1 minus 1 is 0. So we have perfect, right? We basically have no items left. So that's good. We have true here. And in this case, we have false for those items because in this case, if 2 minus 1 is 1, so there's still items left, but there's no items in the array. So in this case, we have to return false. So because there's only one item left, right? In this case, it's only 1 because we're going from bottom to up. So in this case, we're going to return false for every single position, right? So yeah, in this case, and basically yeah, basically here you can see what we're going to do is we're going to start at this position, and we're going to see if, so in this case, the sum is 1, right? The current situation sum is 1. So 1 minus 2, right? So we have two decisions, like I showed you earlier. Either we take the current item, and the current item is 2. Either we take this item, or we skip this item. So if we take this item, what's going to happen is we're going to have this current item 1, right? The sum minus 2. In this case, sum minus 2 is negative 1. So we're going to have a false answer, or what we can do is we can skip this current item. If we skip the current item, then what we're going to do is we're going to have 1, right? In this case, if we skip, then we have item 1 left. But we already know the result for 1 in this case is going to be true. So to retrieve the previous result, all we have to do is we say cache at row minus 1, right? Basically it's the previous row, and add the current sum. So in this case it's true. Or what we can do is we're going to have the previous row, and we're going to take the current item, which is current sum minus the current num, right? So in this case 1 minus 2 is negative 1. So in this case this will give us false, this will give us true. Okay, so now we have to get to this part. In this case 2 minus 2 is 0, right? In this case, or what we can do is we can skip this item, which will give us false, or we can just do this part, which in this case we're going to take the current item. In this case 2 minus 2 is 0. So in this case 2 minus 2 is 0. It will give us true, right? In this case it's true. So we can either take this or we can take false. In this case, if one of those statements is true, then we can just take true. In this case we have true here. Let's take another one. Let's look at another example here. So let's say we have this part, right? In this case we have this part right here. So 3 minus 2, which is 1, right? Or what we can do is we can skip, right? So in this case, what we can do is, if we skip, then the result is going to be false. But if we take the current item, in this case we have 2, right? So 3 minus 2 is 1, and we still have 1 left, right? In this case we still have 1 left. So 1 give us a result of true, right? So in this case, if we have item 1 and the sum right now is 1, then this will give us true. So in this case, if it's true or false, in this case, we take the true, right? So if one of those statements is true, then we take true, right? So pretty straightforward. So now you get an idea, and basically we're just going to compute all the way until we get to the bottom right, and then we're just going to return the result, right? So let's try to do this in code. I'm just going to delete this part. So I'm going to delete this, I'm going to delete this. Okay, so we have the cache, right? So in this case, first we declare the cache. Okay, so what we're going to do is we're going to first declare the first column, right? In this case, because if we have the sum, right? In this case, if we have the sum right now at the situation is 0, then we can just return true, right? So for I is equal to 0, so in this case, yeah, for I is equal to 0, we're going to iterate each and every single items in the, basically each and every single row. For the first item, we're going to set it to true, right? So in this case, I is equal to 0, so we're going to set row is equal to 0. So row is less than cache dot length row plus plus, right? So in this case, we're going to do say cache, right, at the current row is going to equal to true, right? And at 0, right, in this case at the first column is going to equal to true. Okay, that's our first step, right? We're going to set this to true, and we're going to focus on the first row, right? Yeah, the first row. Once we've done the first column, we're going to do the first row. So what we're going to do is we're just going to have iterate, right? In this case, for the first row, we're going to start at the second element. We're going to see if the sum, right, the current sum is actually equal to the current item, right, the current element. If it is, then we're just going to return true. Otherwise, we're going to set false. So let's say current sum is equal to is equal to 1. So in this case, if current sum is less than half plus 1 or cash at 0 dot length, right? So in this case, we're going to set current sum increment by 1. So what we're going to do then is we're going to say cash at current sum, cash at the first row. For the current sum, right? If the current sum, so if current sum is equal to nums at 0, right? So the first element, right? In this case, this is going to be the first element in the array. If it is, then we're going to set this to true, right? Otherwise, what we're going to do is we're just going to set cash at 0 at current sum is equal to false. Okay? So once we figured out our first row, what we're going to do then is we're just going to, starting at this position, going all the way to the bottom right. Okay? So compute each and every single row to the bottom right. So what we're going to do is we're going to start at the current number. So in this case, we have num, or say current num. Current num index starting at 1. So while current num index is less than cache dot length, then we're just going to continue to increment, and if what we're going to do is we're going to have to iterate the entire row. So we're going to have current sum, which is equal to 1, right? In this case, starting at 1. If current sum is less than cache at 0 dot length, then we're going to increment cache sum by 1, right? So what we're going to do is we're going to have a take and a skip, right? So in this case, if we take the current item or we skip the current item. So just like this one right here. This is if we skip, and this is if we take. Okay. Take is equal to cache at the previous row, right? What we're gonna do is we're gonna get the current sum minus the current num, right? So the current num is gonna be nums at current num index. But first we have to see if there is a space, right? If there is a if there's a space for taking this element. So what we're going to do is we're going to have take, which is a boolean by default. By default is equal to false. And what we're going to do is this: if the cache, right? So if cache at the previous row, which is basically going to be current num index minus 1, yep, at my bad. So what we should do is we should see if the current sum, right, minus the nums at current num index, right? So this will give us the difference. If it's bigger than or equal to 0, then what we're going to do is we're going to set take is equal to cache at current num minus 1, which is the previous row, at the current sum. So let's try to store this value in a variable. So in this case we have difference. So diff is equal to this. So if diff is bigger than or equal to 0, then we're going to have this, right? Okay. So that's for take. And for skip, right? So for the skip is basically equal to, in this case, is going to be the previous row at the same sum, right? So basically means that we skipping this current item. So it's going to be cache at current num index minus 1, and the sum is the same. Okay, so what we're going to do is we're going to say cache at current num index at the current sum is going to equal to either we have skip or we have tick. Okay, what we're going to do is we're going to have either tick or skip, right? So either one of them is true, and this position is going to equal to true. So at the end, all we're returning is returning cache at nums.length minus 1, right? So it's going to be the last element, this element right here, at the current, at the sum, right? So sum in this case. Sorry, half. Sorry, my bad. It's going to be the half plus. No, don't plus 1. Yeah, basically it's going to be the half. So let's try to run the code. Okay, so let's try to submit. And here you can see we have our 6 sets. So basically this is how we solve this problem using bottom-up approach. So basically for the time complexity, for the memoization approach, it's going to be big O of n. N is basically number of elements in the array, times the sum, right? The sum of the half of the array. In this case, we have all the elements, the sum of all the elements divided by 2, right? This will give us the time complexity. So, and this is also the space complexity as well. So there you have it, and thank you for watching.